Okay, so now we've got absolute value. Where so far when we've been dealing with absolute values, we've been just saying, okay, the absolute value makes a number positive. The other way to look at it is that what's inside the absolute value can be positive or negative. And so that's sort of what this is saying. And we're going to use that alternate way to look at it in order to solve inequalities that involve absolute values. So when we have inequalities, though, it's a lot trickier than just the equal sign where you have two equations. Because here, the inequality, if you're adding a negative, then that also changes the direction of the inequality symbol. So rather than trying to figure that out all at the same time, you can think of it as there are four different possibilities that you can see involving absolute value inequalities. And then there's four different ways that you can write those. The way I look at it is that if it's a less than or less than equal to, it creates a compound inequality. And if it's a greater than or greater than equal to, it creates two separate inequalities separated by an or. The or is important for finding the solution because or means we are unioning the solution. It can be one or the other. So we're not looking for any overlaps of solutions. We're just saying, okay, wherever we've colored, that's our solution. So for these types, I strongly recommend graphing in order to figure out your solutions because of the fact that we have what is called a union going on because of the or symbol. So it's either one or the other, or it could be both. So that's what that means, basically. So I've got examples going through all four of these possibilities here. So I'm going to just start from the top one and going down. So form one, absolute value of something is less than a number, essentially, or less than something else. So I've got two examples here. So the first one here, absolute value of x minus 7 is less than 5. So if it's a less than, we turn this into a compound inequality. So I've got x minus 7 is less than 5, but then I also have the other side with the negative 5. And then I keep the less than symbol in between those. So I have negative 5 less than x minus 7 less than 5. And now you're solving for x in the middle. So I'm going to add 7 to the three sides. So negative 5 plus 7 is 2. 1x less than 12. And so now I'm solved. And now graphing, I have 2 and 12. My x is in between 2 and 12, but does not include 2 and 12. So those are going to be parentheses. And the parentheses are facing where I'm shading. So my interval notation is 2, 12 with parentheses. See, that's one where it looks like an ordered pair, and so you have to know by context, we're not graphing, we don't have two variables. If there's two variables, x and y, then that's an ordered pair. But we solve something with one variable, so that's interval notation. So you have to know by context based off of how many variables you have. Okay, now the second one here, we've got 1 minus 2x inside absolute values less than negative 5. So same thing, 1 minus 2x less than negative 5. And then on the other side, I'm going to take the opposite, so now that's going to be 5. So I'm going to just, we've got my three sections here. I need to get my x by itself in the middle. So first I need to get rid of the 1. So I'm going to subtract 1 from three sides. 5 minus 1 is 4, less than negative 2x, less than negative 6. Now I'm going to divide everything by a negative, which will reverse the inequality. So I'm dividing everything by -2. So 4 divided by -2 is -2, greater than x, greater than 3. And now we still have the less than, or the small. The key here is we really want to have the smaller number on the, or we want to have, let's see, it's easier to think of as read it left to right. So we want to do the mirror image. So that means I've got 3 less than x less than -2. And now let's think about what this means. 3 is less than x, which is less than -2. Is 3 less than -2? No. We have something that is impossible. 3 cannot be less than 2. Because when you read these left to right, it's basically whatever's on the left has to be also less than whatever's on the right. That's that transitive property. So this is impossible. So this means there is no solution, which we usually hate with a 0 with a slash through it specifically. So that's why never write your zeros with a slash through it, because that means no solution as opposed to the number 0. There's a difference there. We could figure this out immediately from the way the whole equation is set up, because at the very beginning, with the absolute value of 1 minus 2x, which absolute value is always positive, less than a negative number, less than -5. And a positive is never less than a negative. So even before solving it, you could say, oh, wait a minute, my absolute value is less than a negative. That can't happen because the absolute value is always positive, so there is no solution. Okay, so now let's look at what happens when you have a less than or equal to sign, because if you have the equal to there, that can throw some of these things off. You can get some interesting things. So first, I have absolute value of x minus 8 minus 2 less than or equal to 14. So before we rewrite this into the compound inequality, we first have to get the absolute value by itself. So that means that -2 I have to add to both sides before I do anything else. So that gives me the absolute value of x minus 8 is less than 12. Now it's got that less than, so we're making a compound inequality. So I have x minus 8 is less than or equal to 12. And then on the other side, I put -12 is less than or equal to. So now, with my highlighter, so we can see the 3 sections, I need to get x by itself, so I'm going to add 8 to everything. So -12 plus 8 is -4, less than or equal to x, less than or equal to 20. Okay, so now I'm going to make my graph. Put -4 on my number line, 20 on my number line. X is between those two numbers, literally. And then we can include, because of the equal to part, so we can include both of those numbers. So those are going to be brackets facing where we've shaded. So in interval notation, that gives me a -4 with a bracket and a 20 with a bracket. And that's our solution. Now the second example here, this is a special type of thing because we have an absolute value less than or equal to a 0. So 0 doesn't have a positive or a negative version. So we would not need to create a compound inequality. We can just ignore essentially the absolute values, and then basically you would set it up because -0 is the same as +0. So what we have here is 0 is less than or equal to 9 minus 2x, or less than or equal to 0. Well, the only way for 0 on the left to be less than or equal to 0 on the right is if they're equal. So basically, we're saying 9 minus 2x is equal to 0. Because there is no other less than part because both sides are the same. So we're actually solving in here an equation because now we have an equal sign. And if you look at what we originally have, 9 minus 2x absolute value less than or equal to 0, it's never less than it's 0. So that part doesn't even really matter, but it can be equal to 0. So that's the only part we really care about. So we're just solving where it's equal to 0. So if I add 2x to both sides, so that I don't have to deal with any negatives, I get 9 is equal to 2x. And then we divide both sides by 2. You get x is equal to 9 halves. When we graph this, it is just a dot. Basically, at 9 halves, we only have one solution. It's just a closed circle. And when we put this in interval notation, you actually use set notation. And we just put it in a set with a single number, 9 over 2. Because if the absolute value is not going to be less than 0, so it can only be equal to 0. If it had been a less than without the equal to part and said less than 0, that would be another no solution because it can't be less than 0. But we can be equal to 0, so there is a solution here. It's just a single number. Okay, now form 3 where we have the greater than symbol. So I've got two possibilities here. First one, again, because before I do anything, I have to get the absolute value by itself before we do anything else. So I have to subtract the 3 from both sides first. So that gives me the absolute value of x plus 14. Make that better, plus sign. There we go, plus 14 is greater than 14. Because 17 minus 3 is 14. Now, if it's a greater than, we end up with two separate inequalities to solve with an or in between them. We have x plus 14 greater than 14, where you basically are ignoring the absolute value sign. And then you have x plus 14 is less than negative 14. So we have to switch the absolute value, or we have to switch the inequality, reverse it because of the negative there. So now you solve each of these for x. So I'm going to subtract 14 from both sides. We get x is greater than 0, or when I subtract 14, x is less than negative 28. So now when I graph, let's take a look at what this means. I'm going to put negative 28 on here and 0. So x is greater than 0, so that's to the right of 0. Or x is less than negative 28, so that's to the left of negative 28. So we have two separate sections here that are solutions, and we combine these using the union symbol. So on the left, my left endpoint is negative infinity, comma, negative 28, and then I have a parenthesis because it's a greater than, not a greater than or equal to. And then I have a gap, so I have to connect those with the union symbol, which is a big U. And then my next endpoint that I hit is at 0, which is not included, so that's 0. And then that goes to infinity, which also has parentheses. So our solution, we have two separate pieces. Our solution could be in either one. It can't be in both because they don't overlap, but it would be in one or the other pieces. And so any x in those sections can solve this problem. Okay, now let's look at absolute value of x over 2 greater than negative 6. So same sort of thing, absolute value already by itself, so now we create two separate inequalities. We have x over 2 greater than negative 6, and x over 2 less than 6, because you're taking the opposite of your number, and that involves multiplying by a negative basically, so the inequality flips directions, it reverses. Now to solve both of these, we multiply both sides by 2 to get rid of that fraction. So I get x is greater than negative 12, or x is less than 12. So I don't have, because I multiplied by 2, negative, I don't, or it was a positive, I don't have to worry about reversing things. So let's graph what this means. So I'm going to put negative 12 and 12 on my number line. And now highlight. So x is greater than negative 12. So that's to the right of negative 12. X is less than 12. So that's to the left of 12. Well, now everything is highlighted. So that means our whole number line is the solution. So in interval notation, make sure I've got the pen, it says negative infinity to infinity, because our left endpoint is negative infinity, our right endpoint is infinity. So the whole number line is a solution. This is all real numbers for the solution. You can figure that out from the very beginning. You have an absolute value greater than a negative. Absolute value is positive, greater than a negative. Well, a positive is always greater than a negative, so it doesn't matter what x is, it's always going to be true. So you don't even need to solve. You can look at that and think about it critically and say, wait a minute, this is always going to be true. So these absolute value problems involve a lot of critical thinking and considering, what do these equations mean, what are they telling you, before you just go and solve, because you can save yourself some work. Okay, now the last form is where we have an absolute value greater than or equal to a number. So now the first one here, I've got 2 times if the absolute value of x plus 10 greater than or equal to 6. So 2 times an absolute value. You are not allowed to multiply through absolute values. It's not a parenthesis. You can't distribute through there. It does not work that way. So what we need to do is divide both sides by 2 first in order to get the absolute value by itself. So that gives us the absolute value of x plus 10 is greater than or equal to 8. Now I'm going to set up 2 separate equations. I have x plus, or inequalities, x plus 10 is greater than or equal to 8, or your second one, x plus 10 less than or equal to negative 8. So you switch the sign and you reverse the inequality. So now I solve both of these by subtracting 10 from both sides. We get x is greater than or equal to negative 2, and x is less than or equal to negative 18. So now if I look at this on my number line, I have negative 18 and negative 2. I'm going to label my infinities. So x is greater than or equal to negative 2, so that's to the right and includes 2. X is less than or equal to negative 18, so less than is to the left of negative 18 and includes 18. So now, as far as the interval notation goes, at negative infinity, that's the left side, that always has a parenthesis, comma, then my highlight stops at negative 18, and it's included, so I have a bracket facing towards where I've highlighted. Then I have to union the 2 pieces together because we have 2 sections. My next endpoint is at negative 2, and that's included, so it's a bracket facing towards where I've shaded. Then comma, and then I end at infinity, which always has a parenthesis, and that's going to face the shading. So now we've got 2 separate sections, which are the solution to this problem. Okay, so now last one here. I have absolute value of x minus 3 over 2 is greater than or equal to 0. So again, two separate inequalities here. So we have x minus 3 over 2 greater than or equal to 0, and then x minus 3 over 2 less than or equal to 0. All right, so to solve both of these, we can multiply both sides by 2 to get rid of the fraction. So that would be x minus 3 is greater than or equal to, then 0 times 2 is still 0. And then x minus 3 is less than or equal to 0. So now I add 3 to both sides. We get x is greater than or equal to 3, or x is less than or equal to 3. Now I'm going to draw my number line, and I only have one number here, 3. And so when I highlight, I'm greater than or equal to 3, so that goes to the right. And I'm less than or equal to 3, which goes to the left. So the whole thing is highlighted. So this is another one where it's all real numbers for your solution, because your absolute value here is always greater than or equal to 0. That's always going to be true because you have a positive greater than or equal to 0. And that's always true. Now, if it had been greater than 0 without the equal to part, then 3 would not be an answer, and your answer would be everything except 3, because we don't include 3. So that would actually look a little different. So to basically summarize some of these special cases that we have, the ways you can get no solution: if your absolute value is less than 0, the absolute value is less than negative, or the absolute value is less than or equal to negative. You can get infinite solutions if your absolute value is greater than or equal to 0, if it's greater than a negative, or greater than or equal to a negative. You get one solution if your absolute value is less than or equal to 0, because essentially you're just solving absolute value equal to 0. And then you get all real numbers except something when your absolute value is greater than 0. So those are special cases that you have to pay attention to. And you can also figure it out using log once you have your solution and asking yourself what that means.